Even today's most sophisticated hydronic systems can have problems that lead to reduced comfort and higher operating costs. Engineers are challenged with balancing these buildings designed for full load conditions, but 80% of the time operating at partial loads. These systems suffer from low delta T, or low change in temperature. Traditional control valves distribute a fixed flow to cooling and heating coils and requires many rounds of complex CV calculations. During operation, if a valve for one or any of the coils fully closes, the system pressure and the flow changes in the other coils. This creates pressure imbalance within the system, leading to unnecessary increase in flow to other coils, reduced control, inefficient heat transfer, and wasted energy. If we look at a room within the building, we can see that actual temperatures often differ from the set point, so changing the flow affects room temperature and comfort levels. The valve constantly opens and closes, hunting for control, a sign of low valve authority. This system imbalance can affect satisfying required room temperature and overall comfort levels. But the system performs differently when using ABQM pressure-independent balancing control valves, or PIC valves. ABQM PIC valves integrate three functions in one easy-to-use compact design. Control valve, a differential pressure regulator that constantly balances to proper flow, and an adjustable high-limit flow globe control valve with a linear characteristic. When ABQM is assembled with a Danfoss actuator, ABQM provides precise control regardless of pressure fluctuations throughout the system. This means meeting the required set point is achieved in a controlled manner with 100% valve authority and efficient heat transfer across the coil. Good control brings the best return fluid temperature in a system. In addition, installation is simplified as ABQM is selected based on flow requirements, eliminating the need for CV calculations. Let's examine an overall building simulation and the locations where balance and control are critical. The valve assembly is proven to remain in control at the coil location nearest the pump and the furthest from the pump. The required flow at these locations is representative of the temperature requirements within the space. Under full load conditions, these two locations can provide proper control. If the overall building load requirement is reduced to partial load, the result is a reduction of flow and increased differential pressure on the system. For the traditional valve setup furthest away, data provides excessive flow through the coil, resulting in inefficient heat transfer. However, ABQM's response is different. Through the pressure regulator, the balancing mechanism dynamically adjusts for the increased differential pressure from the reduced building load. The regulator maintains a consistent flow across the valve, creating no change in differential pressure while meeting the load requirements. A second scenario involves reduced flow requirement to meet set points at partial load conditions within these two locations. With reduced flow from the coil and the partial load condition, the response observed from the traditional valve oscillates from overflow to underflow as the control valve tries to meet the flow requirements, also known as hunting. The changes to the overall building demand and coil requirements result in lost control. When we observe ABQM in the reduced flow scenario, the PIC valve maintains control and stability to the lower flow requirement, unaffected by the system changes. With PIC valves, flow in the other coils stays unchanged, and so does the room temperature, giving you true independence at either full or partial load conditions. PIC valves optimize hydronic flow and control for maximum energy savings and comfort throughout the building. PIC valves are designed for a wide range of applications and equipment, including variable air volume units, fan coil units, and more. And their performance makes them ideal for both new construction or retrofitting an existing installation. Overall, PIC valves offer significant benefits. They're easier to select, install, and commission, taking the complexity out of balancing your building. The unique design establishes a high-limit flow dynamic, balancing the optimization of the system by maintaining proper flow regardless of pressure fluctuations. This ensures stable and accurate flow control, maintained temperature set points, improved occupant comfort levels, and reduced energy costs by up to 25%. For more information, contact a Danfoss expert or visit our website.